Welcome to our continued lesson on zeros of a polynomial. In question 1, it gives us that -4 is a zero of this function. Find the remaining two zeros. When given a zero, we can use synthetic division to factor the polynomial, which then permits us to find the remaining zeros. We will put -4 through synthetic division. Our coefficients are 1, 4, 9, and 36. Remember, the process is to multiply and then add the numbers in the column. When we do this, we do get a remainder of 0, which tells us that the ordered pair -4, 0 is an x-intercept or a zero of the polynomial. We can now write this in factored form as x plus 4 times the 1x squared plus 0x plus 9. This is our function in a factored form. It's a little odd to put a 0x in the factored form, so let's rewrite this as x squared plus 9. Once I get a quadratic polynomial, the goal is to either factor it, use the square root property, or go to the quadratic formula to get the zeros from the quadratic equation. When I come in here to get the zeros by taking each factor and setting it equal to 0, I get my -4, and then with my x squared plus 9, using the square root property, I get a plus minus 3i. Therefore, the zeros of this polynomial occur at -4, at 3i, and at -3i. In question number 2, again, they give me a zero of the polynomial. So again, I'm going to use synthetic division, and the remainder should be 0. Remember to multiply, but add the columns. It did give a remainder of 0, so now my function written in factored form is x plus 1 times 1x squared minus 4x plus 13. I now have a quadratic equation. Again, I want to factor it if I can, but if it won't factor, I use the quadratic formula. This one will not factor, so I'm going to have to use the quadratic formula to come up with the zeros from this quadratic trinomial. I get the -1 from the first binomial, but the trinomial will require me to use the quadratic formula. I will have a negative of a -4 plus minus the square root of b squared which is 16 minus 4 times a times c all over 2 times a. Now cleaning this up a little bit, this becomes 16 minus 52 under the radical. This is the square root of a negative number. So the square root of a negative number will transition to the imaginary number. And I get 2 plus minus 3i as my zeros from this quadratic equation. Therefore, I have 3 zeros to this original polynomial, and they are -1, 2 plus 3i, and 2 minus 3i. Number 3 is a big change from number 1 and number 2. Now they're asking me to actually find the function, find the equation of the polynomial. To do this, I simply take the given zeros and write x minus that 0. Now all I need to do is some algebra to clean this up. A lot of distribution. In general, we would normally do FOIL on the second two binomials, resulting in an x squared minus x minus 12. And then we would distribute the x and the 2, which is a rather lengthy process. The result becomes a third-degree polynomial, which would be the answer to the question, the function, the actual equation of the line that would have zeros at 2, -3, and 4. In other words, this function will, when graphed, will have x-intercepts at the point 2, 0, the point -3, 0, and the point 4, 0. Number 4 again is asking to find the function, find the equation of the polynomial. So we will do the same thing with the given zeros. We'll take x minus the 1 plus 5i, x minus the 1 minus 5i, and x minus the -2. Be very careful that this becomes x minus 1 minus 5i, x minus 1 plus 5i, and x plus 2. This is your function. Now when you multiply this out, again it's a rather lengthy process, but the trinomial times the trinomial will turn out to be an x squared minus 2x plus 26, noting that the imaginary number is absorbed in the algebraic process. And then when you distribute the remaining trinomial times the binomial, you will get the third-degree polynomial of x cubed plus 22x minus 52, which would be the resultant polynomial with the given zeros. Now in this case, the only x-intercept you will have will be the -2, 0, because the 1 plus 5i and 1 minus 5i are imaginary. They will not be on the graph. Our graph only has real numbers on it. I hope this is helpful in you understanding these higher degree polynomials. And this is the end of this recording.